Okay, welcome back. This is part 2 of lesson 6.1. So let's look at our next example where it asks which sequence is arithmetic or geometric. So I noticed there were some formatting issues here. So notice I crossed this out. This table actually belongs over here. So I rewrote it. So let's look at our two tables. In each one we have n, which is the position. So n 1 through 5 for both, and then what a of n would be equal to at each of those positions. So if I'm looking at this, the first term in this table is 7. And the first term in this table is also 7. Okay? And then this one has a common difference, and that common difference you can see 7, 9, 11, 13, 15 is 2. But in this table, 7, 14, 28, 56, 112, it's not a common difference, it's a common ratio. And that common ratio is 2. Every time I go up a position, it doubles. So let's talk about the recursive and explicit rule then for this first one. Since we've got this common difference, f of 1 is 7. And therefore a of 1, so when a is 1, it would be 7. And so f of n is going to equal f times n minus 1 plus 2. So every time the function goes up or increases, we're taking the result of the function before and we're adding 2 to it. Okay, a of n would be a to the n minus 1 power, or not power, but n minus 1, so that gives us position, and that is also plus 2. So basically these two things are expressing roughly the same relationship, just in a slightly different way. Now the explicit function for this, though, would be first term, 7, plus the common difference, which is 2, times n minus 1. Okay? And a of n would also look the same. 7 plus 2 times n minus 1. And so these are our explicit and recursive. So recursive, these are the formulas, and then these are the rules that these formulas are giving us. All right, now, for this one over here, the other option, where it's a ratio, and the ratio is 2 rather than a common difference, recursive, again, f of 1 is equal to 7. A of 1 is also 7. But now this time, f of n is equal to f of n minus 1 times 2. Every time you take that position, you multiply it by 2, or a of n minus 1 times 2. Okay, basically stating the same thing. So we've got the recursive function, and then we have the rule for that function, which you can see within the function. Now for the explicit's going to be a bit different now because we're not doing, again, we start with the original, the first position, which is 7 times 2, because we're always multiplying by 2, to the n minus 1 power. So that gives us the position. So if we were to go to the second power, well, I would have 2 minus 1. What would 2 minus 1 be? That would be 1. That'd be 2 to the first power. That's 2. 2 times 7 is 14. If I were to go to, let's say, the fourth power, it'd be 4. So n would be 4. 4 minus 1 is 3, and that would be 2 to the third power, and then 2 to the third power times 7, that would give us 56. Okay, you can see how that works quite nicely. And a of n, same thing, because it's the rule. It is just 7 times 2 to the n minus 1 power. Okay, so that's the difference. So Which one's arithmetic? Which one's geometric? This one is clearly geometric because it's going up by ratio rather than going up by some common difference. This is not linear. This one is geometric in its sequence and is going to form a curve, an exponential curve. Okay, so let's look at the next two examples. So we have this table, n's 1, 2, 3, 4, 5, and you can see what's going on. 4, 12, 36, 108, 324. So we want to know, what is the common ratio? Well, the easiest way to find the common ratio is we can take one position and divide it by the position before it. So we can say 12 divided by 4, and that equals 3. Now you might want to check just to make sure it is exponential. Does that occur if you do that in all the other positions? If I take 36 divided by 12, do I get 3? Yes. 108 divided by 36, 3. 324 divided by 108, 3. Okay? So, what this tells us then for the recursive rule tells us that f of 1, the first position, is going to be 4. Semicolon there. And that would make f of n is going to be equal to f of n minus 1 times 3. Or you could say a of 1 equals 4, and therefore a of n is always going to be equal to a n minus 1 times 3. Our explicit rule, on the other hand, though, is going to be f of n is equal to 4 times 3, because that's our ratio. We're always multiplying by 3 to the n minus 1 power. Or we can say a of n equals 4 times 3 to the n minus 1 power. The reason I'm giving you the f of n or a of n is because these are two different notations that you might see. They essentially mean the same thing, but I just don't want you to be confused when you see these two different formats for writing what's essentially the same function in both recursive or explicit. So, look at this next one. It's your turn now. Pause the video, look at this table, and come up with the common ratio, recursive rule, and explicit rule for what you see in this particular sequence. All right, now that you've paused and come back, we want to look at, how do we figure out the common ratio? Well, like I said before, you can take the second or third or fourth or fifth positions and divide it by the position that's before. So I'm going to take negative 4 divided by 8. So the common ratio is negative 1/2. For the recursive rule, we know that f of 1 is equal to 8. And therefore, f of n is going to equal f of n minus 1 times negative 1/2. Or you can say a of 1 equals 8, and therefore a of n equals a n minus 1 times negative 1/2. And that would give us this function. As the explicit rule, it would be f of n equals 8 times negative 1/2 to the n minus 1 power, or a of n, I know it looks like and, but it's a of n, equal to 8 times negative 1/2 to the n minus 1 power. Okay? So, that is, these are the two ways, recursive or explicit rule, that we can use for a geometric sequence. Turn to the next page. It says, the formula for finding the nth term of a geometric sequence with a common ratio r. Anytime you want to find that nth term, and again, that nth term could be anything, it's basically f of n minus 1 is always going to be equal to f of n minus 1 times r, which is that ratio. So let's write that down. R equals the ratio, okay? And we can go from there. All right.